differentiation. The chain rule. So suppose you have a function z equals to f of x and y, and at the same time, your x and your y, both of them are dependent on another variable. So this is your case. Part A, x is, for example, let me follow the note, x is equal to g of t, and your y is equal to h of t. So x and y both depend on a new variable like t. How do you take the derivative with respect to t? In this case, you have two options. First, we can substitute g and h for x and y into the function, then take the derivative with respect to t. Take the derivative with respect to t. Or we can follow the formula. Second, we can follow the formula. The formula says df dt. Here you have just one variable, so you're taking the derivative with respect to t, is equal to partial derivative of f with respect to x times the partial derivative of x with respect to t, plus partial derivative of f with respect to y times partial derivative of y with respect to t. For example, let function f of x, y, x and y be defined as x squared times y plus 3x y to the fourth. So you have a function in two variables and you have distance. X is assigned to t. Okay. And your y is equal to cosine t. Cosine t. This is our example. Perfect. So what are we trying to do? We are trying to take the derivative of function f with respect to variable t. What is the derivative of f with respect to t? What is this guy? We can follow the first method, use substitution. So how substitution works here, you can plug in sine for x and cosine for y, and then start taking the derivative. Or you can apply the second method. Second method says, well, we have to take the partial derivative of f with respect to x. Partial derivative of f with respect to x is 2xy plus 3y to the fourth. So this is partial derivative of f with respect to x times partial derivative of x with respect to t. So remember that here, the derivative of sine 2t is equal to 2 cosine 2t. This is the chain rule that you learned in elementary calculus. Okay, you multiply that by 2 cosine 2t. Partial derivative of x with respect to t. Plus sine addition, partial derivative of f now taken with respect to y. Well, with respect to y, it means that your x is a constant. So parentheses, taking the derivative with respect to y, it gives you x squared. Taking the derivative with respect to y, you get 3 times 4, which is 12 x y to the third. So this is partial derivative of f with respect to y times partial derivative of y with respect to t, which is super easy for you. The derivative of cosine is negative sine. Well, we don't stop here. Why is that? Because we wanted to take the derivative of f with respect to t. But here you see variables x and y. We have to do the substitution. So since we have x and y, we need to do the substitution. This is going to be equal to 2 times x. What is x? X is sine 2t. 2 times sine 2t times y. What is y? Cosine t times 2 cosine 2t plus x squared, sine squared of 2t plus 12 times x sine 2t times y to the third cosine to the third times negative sine t. Okay, I forgot to write down plus 3 y to the 4. Please fix that. So this is equal to 2 sine 2t cosine t plus 3 cosine to the 4. Here we go. Thank you. So more formulas for you. The chain rule, if we have more than one independent variable, it's going to be pretty much the same. But now, suppose instead of having just t, your x and y are dependent on t and a new variable like s. The chain rule B. So let z be f of x and y, and x and y are dependent on 2 new variables. Let x be equal to g of, let me follow the note with notation, s and t, and your y is h of s and t. So x and y are dependent on 2 new variables like s and t. So how do you take the derivative of this function with respect to these 2 variables? So since we want to find the derivatives of f with respect to s and t, we have to take the partial derivatives of the function. So partial derivative of f with respect to s and partial derivative of f with respect to t. So here you take the partial derivative of f with respect to x times partial derivative of x with respect to s plus partial derivative of f with respect to y times partial derivative of y with respect to s. Then you move on to t. Partial derivative of f with respect to t is partial derivative of f with respect to x times partial derivative of x with respect to t plus partial derivative of f with respect to y times partial derivative of y with respect to t. Two partial derivatives. Implicit differentiation.
Professor, I guess you are not sharing the whiteboard anymore.
Oh, here we go. Thank you. Implicit differentiation.
Professor, I think some of us in the chat didn't finish writing stuff down because the board disappeared.
I'll post a screen.
So 3 formulas for you. Just taking the derivative with respect to different variables. These are your implicit differentiation. Okay, so let me ask you this. Let's have a 5 minutes group activity if you agree. Okay, perfect. So let me open up the breakout rooms. Okay, just please give me a moment. Let me answer to chat questions. Yes, of course. 2. And let's see. Definitely. 5, sure. Then 4, definitely. Okay. Let me add the questions so everyone has access to the questions. Eight, sure. So you are now in 2. Let me send you to 8. Of course.
Hi, Professor.